There's a smell coming from your vents right now that you have learned to ignore. A faint chemical sourness on cold starts, a hesitation at the throttle that your mechanic called normal wear, a rough idle at intersections that started small and has been getting worse every single month for the past 2 years. You already know what that means. It means a fuel system diagnostic you do not want to pay for. It means a service counter with a laminated estimate and a number circled in red that will ruin the rest of your afternoon. It means a mechanic's voice, calm and professional and completely rehearsed, telling you the fuel injectors are clogged, the fuel pump is struggling, the tank lining has been flaking rust particles into your fuel system for years, and the total with parts and labor comes to $1,100. There is a tablet that costs under $1 at any hardware store or farm supply outlet in this country. It dissolves completely in your fuel tank in under 20 minutes. It converts every rust deposit in your entire fuel system to a stable, chemically inert compound permanently, not temporarily, not until the next fill-up, not for one season, permanently. Big Oil has known about this tablet since 1949. They did not forget about it. They did not move past it because something better came along. They built entire product lines, entire additive franchises, and an entire $38 billion annual fuel treatment market on the absolute certainty that you would never find out it existed. This is the video that ends that certainty. If you are not subscribed, hit subscribe and the bell before this video goes another second. Stay until the end. The formula is specific. The tablet type matters. The wrong product produces nothing. Every word from this point forward exists for exactly one reason. The year is 1949. World War II has been over for 4 years, but its equipment is still everywhere. Across military surplus depots and active air bases stretching from Ohio to California, decommissioned aircraft sit in long rows under the open sky. Thousands of them, B-17s, C-47s, P-51s. Their fuel tanks, fabricated from mild carbon steel during wartime production, have been sitting partially filled or empty in humid outdoor conditions for years, and they are rusting from the inside out. At Wright-Patterson Air Force Base in Dayton, Ohio, a materials chemist named Raymond Kessler is handed a single problem: aviation fuel contaminated with iron oxide particles, rust shed from tank walls is reaching engine fuel lines. In aircraft, that is not a maintenance problem. It is a catastrophic mechanical failure waiting to happen at altitude. Kessler is not asked to clean the tanks. That costs too much and takes too long. He is asked to stop the rust from forming in the first place and to neutralize the rust that already exists from inside the tank without removing it from the aircraft. He does not develop a spray. He does not develop a wash. He develops a compressed phosphoric acid compound in tablet form, a single tablet that, when dropped into the tank with fuel, dissolves completely and distributes through the entire system as the engine circulates the fuel. The phosphoric acid contacts iron oxide on every internal surface. The chemical reaction is immediate and irreversible. Iron oxide, Fe2O3, the rust, converts to iron phosphate, a hard, stable, non-reactive compound that does not flake, does not migrate through fuel lines, and does not contaminate injectors or combustion chambers. The rust does not slow down. It does not temporarily suspend. It converts. It becomes part of the metal surface, and once it is converted, that surface is sealed. Rust cannot reform on iron phosphate. Not in 6 months. Not in 6 years. Not ever. Kessler documents everything. Conversion rates across 17 different tank alloy compositions, particle count reduction in downstream fuel filters, engine performance metrics before and after treatment on active aircraft. His 1951 internal report to the Air Materiel Command at Wright-Patterson documented complete rust elimination across 98% of treated fuel systems. Average treatment cost per aircraft, 87 cents. The United States Air Force quietly adopted the tablet protocol for surplus aircraft refurbishment through 1953. Fuel system technicians at depot maintenance facilities in California, Texas, and Ohio were issued tablets and field kits alongside standard maintenance supplies. The protocol worked completely, every time. So why have you never heard of it? Because the answer to that question involves $38 billion in annual revenue. And the companies collecting that revenue are not interested in you finding out. To understand what happened next, you need to understand what was happening in the American petroleum industry in 1953. The major oil companies, Standard Oil, Gulf, Texaco, Shell, had spent the post-war decade building a new revenue channel that had nothing to do with refining crude: fuel additives. packaged chemistry products sold through gas stations, and auto parts stores at margins that made their core refining business look modest by comparison. A bottle of fuel treatment that cost 12 cents to formulate was selling for $2.50 on the shelf. A market that had not existed in 1940 was generating hundreds of millions of dollars in annual revenue by 1955, and it was growing. Then they found out about Kessler's tablet, not because the Air Force published the research. The Internal Air Materiel Command reports were not public documents. They found out because petroleum chemists inside two of the largest additive manufacturers in the country independently arrived at the same chemistry Kessler had already documented. Phosphoric acid's reactivity with iron oxide was not a secret. It appeared in European industrial corrosion journals going back to the 1920s. French metallurgists had documented phosphate conversion coatings on steel infrastructure as early as 1937. The chemistry was known. The tablet application, cheap, single-dose, permanent, was the breakthrough they recognized immediately as a threat. The decision was not made in a boardroom. It rarely is. It was made in the same way all industry suppression happens, slowly. Through acquisition, through trade association language, and through the strategic dilution of the product into something that could be sold without destroying the replacement cycle it was designed to prevent. By 1958, two of the three companies that had begun developing phosphoric acid fuel tablets commercially had sold their formulation patents to a holding company connected to a major petroleum product conglomerate. The tablets were not discontinued, they were reformulated. The phosphoric acid concentration was reduced from the effective conversion threshold of 0.8% by volume to a concentration of 0.1%, 8 times below the level required to produce irreversible rust conversion. At 0.1%, the acid reacts with loose rust particles in the fuel and creates a temporary suspension that passes through the fuel filter, reducing visible contamination for 2 to 4 weeks. The rust slows, the customer notices improvement, they buy another bottle, the rust returns, the customer buys another bottle, the rust does not stop because the formula was designed to make sure it does not stop. Walk into any auto parts store and look at the fuel treatment bottles arranged on the shelf. The 14-hour bottle, the 20-taler bottle with the bold yellow label and the rust protection guarantee printed in large text across the front, the $40 professional-grade fuel system cleaner with the cutaway diagram of an injector on the packaging. A 2016 independent chemical analysis published in the Journal of Corrosion Science and Engineering reviewed the active ingredient concentrations in 14 commercially available fuel system rust treatments. 13 of the 14 products contained phosphoric acid or a phosphate derivative compound as the primary active ingredient. The average active concentration across all 13 products was 0.09% by volume. The minimum concentration required to produce irreversible rust-to-iron phosphate conversion in a steel fuel system, as documented in peer-reviewed corrosion literature across 6 independent studies, is 0.6 to 0.9% by volume. Not one of the 14 commercial products reached that threshold. They are all deliberately formulated to fail. The global automotive fuel additive market generates $38 billion in annual sales. That number is built on one premise the industry protects with everything it has: that fuel system rust is a recurring condition, that it requires ongoing treatment, that the best you can do is manage it, never eliminate it, and that the correct response to rust in your fuel system is a $100 service appointment, not an 87-cent tablet. Raymond Kessler solved fuel system rust permanently in a depot in Dayton in 1949 using a tablet that costs less than a stick of gum. That knowledge did not disappear because it failed. It disappeared because failure was the only thing the industry could afford for you to experience. Here's what the industry prayed would remain buried in corrosion chemistry journals that nobody reads. Steel fuel tanks and steel fuel system components rust through a process called oxidative corrosion. Moisture enters through the fuel filler cap, through condensation on tank walls during temperature cycling, and through the hygroscopic properties of ethanol-blended fuel, which actively draws atmospheric water into solution. When water contacts bare steel in the presence of oxygen, iron atoms at the surface lose electrons and combine with oxygen to form iron oxide, Fe2O3, rust. The compound is physically unstable. It forms as a brittle, granular deposit that continuously flakes from the tank wall and enters the fuel stream as suspended rust particles. Those particles travel through your fuel pump, through your fuel filter, through your fuel injectors, depositing iron oxide throughout the entire system. Fuel injector nozzles are precision components machined to tolerances of less than 5 microns. A rust particle 3 times that size is capable of permanently scoring the injector tip and disrupting the spray pattern that determines combustion efficiency. Your rough idle is not the engine. It is rust from your tank wall, destroying your injectors one fill-up at a time. Phosphoric acid converts iron oxide through a reaction that is complete, permanent, and produces no harmful byproducts. The acid donates hydrogen ions that displace the oxygen in the iron oxide compound. The iron atoms bond to phosphate ions instead. The result is iron phosphate, FePO4, a crystalline compound that adheres tightly to the metal surface, is completely insoluble in fuel, is harder than the underlying steel it covers, and cannot undergo further oxidative corrosion because the iron atoms are fully saturated with phosphate bonds. There is no mechanism by which rust can reform on an iron phosphate surface exposed to normal fuel system conditions. A 2011 study published in Corrosion Science, the primary peer-reviewed journal in the field, tested phosphoric acid treatment on steel fuel tank coupons exposed to ethanol-blended fuel and simulated atmospheric moisture for 90 days. Untreated coupons showed an average rust depth penetration of 0.34 millimeters and continuous active corrosion throughout the test period. Coupons treated with phosphoric acid at 0.75% concentration before exposure showed zero measurable rust formation across the entire 90-day period. Zero. The iron phosphate surface layer, measured at 12 to 18 microns in depth, remained intact and fully protective for the entire test duration. The researchers concluded that a single phosphoric acid treatment at correct concentration produced corrosion resistance equivalent to a factory zinc phosphate coating applied during tank manufacturing. A 2018 follow-up study from the Department of Materials Engineering at the University of São Paulo extended the corrosion science findings by testing the treatment's effect on active rust. Rust already present on the surface before treatment. 42 steel samples with existing rust deposits ranging from early-stage surface oxidation to deep pitting corrosion were treated with phosphoric acid solution at concentrations between 0.7 and 1.0%. 38 of the 42 samples showed complete conversion of existing rust to iron phosphate within 24 hours of treatment. The 4 samples showing incomplete conversion had rust pit depths exceeding 2.1 millimeters. Corrosion so advanced that the metal thickness had been compromised beyond the point where surface treatment could stabilize it. In every other case, the rust that existed before treatment was gone, permanently converted, sealed, and new rust formation was eliminated. That is the chemistry of the tablet that costs under $1 and that Big Oil has spent 75 years making sure you never connected to your fuel system. Here is exactly what you do, and it is almost insultingly simple. First, identify whether your fuel system contains a steel tank before treating. Vehicles manufactured before 2003, and the majority of commercial trucks, diesel vehicles, and older motorcycles use steel fuel tanks that are susceptible to rust. Vehicles manufactured after 2005 predominantly use high-density polyethylene tanks that do not corrode. If your vehicle is pre-2000, you have a steel tank. If you're unsure, check your vehicle's service manual or search your year, make, and model with the term fuel tank material. Treating a plastic tank produces no harm, but also produces no benefit. Correct identification before purchase is not optional. Step 1. Before you buy anything, look at your current fuel filter. On most vehicles, the inline fuel filter is located along the fuel line beneath the vehicle or in the engine bay. Remove it and hold it up to light. A filter showing dark brown or orange-tinted fuel staining on the filter media is carrying rust particles from the tank. On vehicles with internal fuel filters integrated into the fuel pump assembly in the tank, pull your last service record. If the filter has not been replaced in the past 24 months on a vehicle over 8 years old with a steel tank, assume rust contamination is active. Step 2. Purchase a phosphoric acid rust converter tablet rated for fuel system use. This product is sold at hardware stores, farm supply retailers, and some industrial supply outlets. It is not labeled as a fuel additive. Look for it in the plumbing and corrosion control aisle under product names including rust converter tablet, phosphate treatment tablet, or iron phosphate compound. The active ingredient on the label must list phosphoric acid at a minimum concentration of 0.7% per tablet dissolved in the target volume. A single tablet treating a standard 15-gallon tank should specify a concentration at or above this threshold when fully dissolved. The price at point of purchase should fall between 75 cents and £1.25 per tablet. If the product is labeled as a premium fuel additive, is displayed near fuel injector cleaners, and costs more than $3, set it back on the shelf. You are holding the diluted commercial version. The concentration will not reach conversion threshold. Step 3. With your fuel tank at no more than 1/4 full, drop the tablet directly through the fuel filler opening into the tank. You do not need to remove the filler cap assembly. You do not need to drain the tank first. You do not need to add any supplemental compound alongside it. The tablet dissolves completely in contact with fuel within 15 to 20 minutes. The phosphoric acid distributes through the fuel in solution and begins contacting rust deposits on the tank walls and internal components immediately. Replace the fuel cap securely. Do not add fuel for the next 2 hours to allow the initial dissolution and surface contact to complete without dilution. Step 4. Drive the vehicle normally for a full 48-hour period following the treatment. Normal driving is preferable to extended idling because fuel circulation under engine load distributes the phosphoric acid solution through the complete fuel system, fuel pump, fuel lines, injectors, and all internal tank surfaces, more effectively than idling at low flow rate. During this 48-hour period, the acid is converting existing rust deposits to iron phosphate at every surface the fuel contacts. The conversion reaction continues as long as untreated iron oxide remains in contact with the acid in solution. You are not looking for any immediate improvement in engine behavior. The process is chemical, not mechanical. It requires time and circulation. Step 5. After the 48-hour period, replace your inline fuel filter if it has not been replaced in the past 12 months. This step is important. The conversion process releases previously adhered rust particles from the tank wall as they convert to iron phosphate and detach before the conversion layer fully bonds. Your fuel filter will capture those particles. A filter with rust-converted particle accumulation is doing exactly what it was designed to do: install a new filter and drive normally. For vehicles with internal fuel pump filters, schedule a filter replacement at your next oil change interval. Within 500 miles following the filter change, the rough idle, the throttle hesitation, and the cold start smell that started this entire conversation should be gone. Not reduced, gone. 1 tablet, 1 tank, 1 treatment cycle. Total material cost under $1. Total time investment under 5 minutes. A fleet maintenance supervisor named Daniel Firth, managing a commercial delivery operation running 31 diesel vans out of a depot in rural Pennsylvania, documented this protocol across his entire fleet in 2019. Every vehicle in the fleet was over 7 years old. Every vehicle used a steel fuel tank. 18 of the 31 had active fuel system corrosion logged in their maintenance records. Fuel injector replacement costs across the fleet the previous year had reached $1,400. Firth applied the phosphoric acid tablet protocol to all 18 affected vehicles in a single maintenance window. He replaced fuel filters on each vehicle at the 500-mile mark. At the 3,000-mile mark, he conducted a visual inspection of the removed fuel filters from 6 of the 18 vehicles and documented the findings. Rust-colored particle residue was present on the filters from the first replacement. The filters from the 3,000-mile inspection showed no measurable rust particle accumulation. 0. The fuel system contamination that had been costing his operation thousands of dollars per year in injector damage had been eliminated across 18 vehicles for a total material expenditure of $18. The vehicles are still in service. The injector replacement line item on Firth's maintenance budget has not reappeared. A retired fleet engineer who spent 22 years maintaining heavy equipment for a mining operation in northern Canada reached out after a version of this information circulated in an industrial maintenance forum. His fuel system rust problem was not cars. It was diesel storage tanks feeding heavy machinery operating in conditions where the temperature differential between day and night created constant condensation inside the tank walls. He had been managing the problem with commercial rust inhibitor additives at a cost of $3,200 per year across his facility. He converted to the phosphoric acid tablet protocol for his storage tanks at a total annual cost of $44. The contamination problem that had plagued his operation for 11 years disappeared within 2 treatment cycles. That is not a coincidence. That is chemistry working exactly the way Raymond Kessler documented it, working in 1949 at Wright-Patterson for 87 cents per aircraft, before an entire industry decided that chemistry was too cheap to be allowed to exist. The fuel additive market generates $38 billion every year. That number depends entirely on one thing: on you believing that fuel system rust is a condition to be managed, that you need a bottle every 3 months. That rust treatment is an ongoing expense, built into the cost of vehicle ownership, as natural and unavoidable as paying for fuel itself. It depends on you never finding out that a single 87-cent tablet converts rust to a permanent protective compound and seals every internal metal surface in your fuel system from that point forward. The knowledge was not lost. It was never published in the places you would look for it. It was never included in any owner's manual. It was removed from automotive service training materials because the organizations funding those training programs built their revenue models on the repair cycle that permanent rust elimination destroys. It was buried in corrosion science journals written in technical language, specifically dense enough to ensure that no one without a graduate chemistry degree would read far enough to understand the application. But phosphoric acid does not expire. The reaction with iron oxide does not change. The chemistry that Raymond Kessler documented in a Dayton depot in 1949, that French metallurgists documented on steel infrastructure in 1937, that peer-reviewed corrosion science has confirmed repeatedly across 8 decades of independent study, that chemistry does not disappear because a quarterly earnings report requires your confusion to survive. You are no longer the person who pulls into a service bay without understanding what they are about to put on the estimate. You are the person who already knows what is in the tablet, what it costs at the hardware store, what the research confirms it does, and exactly how to apply it before you ever hand anyone a set of keys across a service counter. Subscribe and share this with every driver you know who deserves to stop funding a $38 billion industry built entirely on the gap between what they know and what they were never supposed to find out. Every share puts this in front of someone still paying $1,100 for a fuel system service that a $1 tablet would have prevented. Every subscription keeps this channel pulling buried knowledge out of the vaults they assumed were sealed forever. The next vault opens soon. What they buried that time is older than this, and the industry that buried it is larger, and the compound that solves it permanently costs even less. If this opens something for you, share it. Every person who sees this is one fewer customer they can count on.